In this problem, this is basically what we're told, that we have some 720-degree angle, and it can be written in radians as a pi, where a is a constant, and we want to find the value of a. So the main thing here, there's two ways to do it, but basically if you just recall that in radians, 360 degrees is actually equal to 2 pi. So like if you have a circle, the full, if you go all the way around, that's 360 degrees, and in radians, that's 2 pi. So from here you can sort of, I guess, set up a proportion, like 360 over, 360 to 2 pi is 720 to a pi. So if this is that, this and this. So from here you can, solve it. I'm sure you kind of already see what it's going to be. But if you go ahead and solve this proportion, I guess, formally, you basically, this collapses to 180 over pi is equal to still a 720 over a pi. We can cross multiply, so scoot over here. We get 180 a pi is equal to 720 pi. Divide both sides by pi. That cancels out, so we have 180 a equals 720, and divide both sides by 180 to solve for a. We get that a is equal to 4. Another sort of simple way you can do it is by knowing that your conversion between radians, so radians to degrees is taking your value in radians and multiplying it by 180 over pi. Think of it as, since radians has a pi value, and has a pi, and you want to get rid of it to get to degrees, that's why it's on the bottom, to cancel out the pi. If you're going degrees, if you're going degrees to radians, you do degrees times pi over 180, and I think about that because radians often have pi, so I want to add a pi in there, so I multiply it by pi. So in this case, you have 720 degrees. You want to get to radians, so you multiply this by pi over 180, and you get the same thing. You get 720 pi over 180, which is just 4 pi. So again, you'd get that a is equal to 4.